Hi all. In this lecture, I will attempt to explain what is a deep neural network. To start, let's dissect the title into three parts: neural, networks, and then deeps. So let's try to illustrate what does neural mean. And to best illustrate that, we can do it with a graph. Let's say this is an iPhone version. The value of it will be on here, and down here will be the years. So basically, we know that the value goes down with the years. So a brand new iPhone value would be up here, and then with the years, the value goes down. This is, of course, a very simplistic example. We see there is a strong negative correlation between the value and the years the iPhone has been used or released, or since the date of release. How can we model this relationship? So let's say at year 1, we know that the value, for example, will be $500. But for example, at year 3, the value will drop down to $150. To model this relationship between X, which is the year, and Y, which is the value, let's say in our case that was $500, and we want to, if the year was 1 and the value is $500, or if the year is 3 and the value is $150, this can be basically this can be calculated using a neuron. And basically, a neuron is a placeholder for a mathematical function. A function can be a Relu, a sigmoid, or a linear function. I posted a link down below if you want to know more about the details of the type of functions. So basically, the neuron takes in a value, multiplies it, divides it using some sort of linear function, and you get an output. So this is a function of a single neuron. Now, what is a network? Let's take this example and try to make it more realistic. So yes, we do have the years an iPhone has been used, but we also care about the storage space. So a 64 gig will not be the same as 256 gigabytes. Let's talk about the cracks, if there's cracks or not, and perhaps the condition. Is there a lot of wear on the phone? Or is it as good as new, although it's 3 years old? So all of these can be calculated as inputs. So we'll give them all x1, x2, x3, and x4. And all of these can go into a neuron, and you get a value out. But to increase accuracy, you will need several neurons, and that's of course according to the literature study that has been done. So let me do this. So what we actually have here is several mathematical placeholders that contain several functions. So if it takes in a value, so if the year was 1 and the storage space was 64, and let's say there was no cracks and the condition was good, all of these values go in here, and let's say, and it comes out here, and let's say it comes out with a value that's 3.5, or the way is 3.5. And so with this one, it takes in the same amount of values, and let's say it comes with 2, and the lower neuron comes out with minus 1.5. These values are fed into another neuron, which takes it in and then spits out another value that says $175. So the mathematical functions that happen inside of these neurons are actually going to create the output value. A stack of these are considered a neural network. So a group of neurons connected together is considered a neural network. So where does the word deep come from? I have to exit here to get the eraser. And we will just delete these 3 lines and get this back. And basically, the term deep comes if you have multiple neurons connected between the input and the output. So again, they're all connected like that. I guess it's messy, but I think you get the point. And a layer here of neurons becomes the deep part, and this is what we now can call a neural network. So what we're looking at now here is actually a deep neural network, which is a group of stacked neurons connected together between the input and the output. Now, if you have the input value and output value, we can also introduce the term supervised learning. Supervised learning is basically learning the functions between the input and the output. So if we consider all of these as x and the output is y, the function that maps the values of x to y, given that you have both of these values, that is considered as supervised learning. And the function, which is a result of supervised learning, can be used to predict all future values. So if we look back into this simple example, if we get, for example, 1.23, if that's the year, so we know that it's going to be somewhere here. And then the function is going to come and map out, and oh, this iPhone is going to cost $430. But instead of having it on such a simple scale, which is only years, the neural network is going to take all of these values as input and predict the output, which is value y. So that is in simple terms what supervised learning is. Now, structured data is basically any data that can be stored in a relational database with very limited amount. For example, the years can be stored as a value 3. Storage space can be simply be stored as 64. The crack 0 can be for no and 1 can be for yes. So that can be stored as a value. And the condition can be, we can add 0 to 3, where 3 is a very good condition and 0 is a bad condition. So these simple values here are considered as structured data because they have a structured schema. They can be stored in a relation database simply and straightforward. Now, unstructured data is something like videos, images, music. Since these things cannot be stored directly into a relational database, basically anything that's not a structured data is unstructured data. And these are very important to highlight before we delve deep into the details, is because we cannot feed the videos straight into a neural network. We can't feed an image straight into a neural network. We can't feed music. We have to take it through a process first. However, with structured data like these, we can feed them straight into the neural network. There's, of course, methods to improve accuracy like feature engineering and other methods, but for now, we can focus on the simple basics. And that is, ladies and gentlemen, a simple introduction to deep neural networks. Thank you.